I want to draw a circle on the canvas. Let's make a variable called x position. Let's start from 0 and let y position also maybe 100. Let's draw a circle with x position, y position, and a diameter of 100. So now we see the circle. To make the circle moving, let's make a function called moving circle, right? And we'll move the draw of the circle inside this function. And every time we call the function, we'll add 10 to the x position. So by the time we call this in the draw loop, the x should increase and the circle should be moving. Okay, now it's working. It's moving a bit fast. Let's make it 5. Yeah, it's better. Okay. What's the next thing we want to do? We want the circle to bounce back when it reach the end, right? So we're gonna create another function called bounce. Let's think about it. How do we make the circle to bounce back? So when the x position exceeded the width of the canvas, right, it should go back rather than keep increasing. So let's say if x position is larger than width, then what do? It should decrease. So it's essentially rather than add 5, we should minus 5, right? X plus minus 5. Else x plus add 5. And we'll replace this with bounce. Okay. So if I run this, we're kind of seeing a problem, right? The circle is kind of stuck at the edge. This is because we're checking the x position with width. When it's greater than width, we're subtracting 5. But once that happens, it's smaller than width again, and we are adding 5 right back up. So what we actually want is for the speed of this circle to be inversed. And once it reaches the edge and reach the boundary, it will be inversed. So let's create another variable to keep track of the speed. Let's say 5. And instead of directly modifying the x position, let's say x speed equals the inverse of x speed. And we still add the speed to the position. Now we're seeing it bouncing back, but it goes through the other side. So we need to add one more condition with this OR operator. If when x position is larger than width or x position is smaller than 0, we'll inverse the speed. Okay, it's working now. So we have a circle that's bouncing. But see if I try to add another circle to it. What will happen if I try to have 2 circles, one right here and one right here, all bouncing? If I try to use the same function to draw another circle, it's still using the x and y position and speed of the variable I created, right? So I need to make the position a parameter I pass in rather than a global variable. Okay, so we passed in the y position. For the first circle, we're passing 100. For the second, we're passing maybe 400. If I run this, we can have two circles bouncing on the screen. But have you noticed something different? It's going faster than just one circle. Let's add one more circles. You can see that the circles are going faster and faster. The more I call the circle, and the faster it goes. This is because all the circles are relying on the same global variable, and every time I call moving circle, it's calling bounce. Every time I call bounce, it's adding the speed to the position. This is leading to some unpredictable behavior that the more I call this function, the faster it goes. This is why you don't want to directly modify the global variable from a function. So let's get rid of the circles and rethink how we can refactor the code to make it better. So we'll have a look at the principles. So we focus one thing at a time, and we try not to modify global variable from the local function as much as possible. So if we think about what is bounce doing, it's actually checking the position against the width of the canvas to see if I want to reverse the speed. So instead of getting these global variables, we can pass in the position and speed. And by checking the position and the speed, I can then modify the speed. But the modification only stay within the function right now, because this x speed is no longer a global variable. It's a local variable passed in as a parameter. So we need to get this modified speed out with a return statement. So we'll need to refactor the circles as well. So what is happening in the moving circles? So it's drawing the circles and calling the bounce. But we want to focus on one thing at a time, which is drawing the circle and comparing the speed, modifying the speed. So we can actually get rid of this function. And then we just draw the circle at x position and y position. Let's say y position. Okay, we need to get a y position equals 100. X position, y position, and the diameter is 100. And then we try to modify the speed, which is controlled by the x speed and x position. So the next thing we do is we want to use bounce and pass in the x position and x speed we already have. So if the x position is greater than the edge, it's greater than the width, well, it will return a new x speed. So we need to reassign this new speed back to the variable we just created. And then we need to add the speed to the x position. We can safely have one circle moving. So if we want another circle, we need to create another set of variables to keep track of the position and speed. Let's say x speed 1, x speed 1, x speed 1. And we can see a circle. We can use the same circle, but with passing the different parameters. And the y position should be 400. And we can even create another one. as a position of 250. So now we have three different circles moving, and we can even assign different speed to them. So by this point, it should be able to write a clean function. That's how we call these functions. It does not modify anything outside the scope of this function, but it's taking input and returning an output. So it's keeping all the logic enclosed without modifying what's outside the scope. And we pass in these parameters, and then we do the modification outside the scope of this function. So this is how you can make the function reusable. It's generally a better practice for using global variables in every function.